In this video, we're going to be talking about the fundamental formulas in physics that you must memorize or you must know. But you must not memorize all the formulas. All you need to do is to know the structure of these particular formulas. So in this, I'm going to suffer to memorize physics formulas again. Physics will become so simple and so familiar with you. I hope this tutorial, if today is your first time, please subscribe as we begin. You'll see that it is the triune physics. Triune means three agreeing in one. So if you observe, as I'll be showing you the structure of these formulas, you're going to see that they are in threes: 1, 2, and 3. You will see the structures of formulas. Everything agree in 3. So as we progress, please pay attention to this so that it will also help you to memorize these formulas and know how to apply them and which topic they fall under. If you are ready, let's go. So let's begin with the first structure now. The first structure, I capture the linear multiplier, right? The linear multiplier, the straight line multipliers, and they come in the structure of y, okay, equals x multiplied by z. This, you can see the structure here. Y equals x multiplied by z. So all you need to do is to identify what y represents, then what x represents, and what z represents. Are we together? So one quantity changes directly when either of the other quantity changes. That's what this one means. One quantity changes directly, let's say x or z, when either of the other quantities, any of this, changes I take it again. One quantity changes directly when either of the other quantities changes. So when either of these quantity, if they change, then this will change directly to any of these particular quantity. So these are the core physics examples when it comes to the formula. Number one, I have F equals ma. F is force. Now F is taking the place of y. AM is taking the place of x, and A is taking the place of z. Alright? Then, if you observe, force is the same thing as weight. So it is this force that you convert to weight. And this mass remains, and then acceleration changes to gravity. The same SI unit. This gives you weight. Then as you progress, you will see that momentum as P equals mass multiplied by velocity, which gives you momentum. Can you observe this? This is mass, this is mass, this is mass, this is acceleration, this is acceleration, this is velocity. All right. Then we have voltage now under current, under Ohm's law, equals IR. Over here, you can see that V equals IR. The same structure, the same core DNA being used in generating this particular formula. So once you understand this DNA, I'm telling you, you'll be able to recall most of the formulas. You can see with this DNA, you can recall up to how many formulas? 11 here. You can recall up to 11 different formulas from here. Then we have our wave equation, which is V equals F lambda. V equals F lambda. I'm going to connect this to the second structure when we get there, the foundational formula. So from this, we are bringing in frequency, which is why it is taking this particular shape. So velocity equals frequency multiplied by wavelength. Take note of the structure. Then we have for electrical power, power equals voltage multiplied by current. Voltage multiplied by current. Then you see that mechanical power is what? Force multiplied by velocity. Force multiplied by velocity. So take note of this. Then we have latent heat of vaporization and latent heat of fusion taking the same shape. Can you see that Q equals ml of vaporization or Q equals mLF of fusion? Please take note of this structure. Then as we progress, also observe, what do you see here? Frictional force equals mu multiplied by upward reaction. So this is the formula for friction, and for Hooke's law, F equals kx. Can you see the structures of this formula? So what you need to know is the structure. Once you remember the structure, you can easily recall some of these formulas. So what are the pattern recognition from here? What do you observe? For force, you have mass times acceleration. For momentum, you have what? Mass times velocity. For voltage, you have current multiplied by resistance. For wave speed, you have frequency multiplied by wavelength. For power, you have voltage multiplied by current. All follow the same multiplication structure. Is that clear? So bullet summary from here based on what you should be able to recognize. Direct proportional relationship. Increasing X increases Y. Remember ing and ses. Increasing z increases y. No inverse terms, take note of this. And then no squares involved in this particular structure. The simplest formula structure in physics is this particular structure. Take note. Then the foundation of mechanics, electricity, and waves, they are gotten from this structure. So if you are happy with this secret, let me know what you think in the comments, and if it will help you memorize these formulas so easily. Now, before I jump into the other part, watch. For Hooke's law, you can see the structure of the formula. Restoring force equals constant multiplied by extension. This is the pictorial depiction of Hooke's law. And for current, which is under Ohm's law, you have your resistance, you have your current flowing, and then you have your voltage source, which is your EMF. And then we have the wave equation, you have your wavelength, you have your wave speed, and then you have your frequency coming from period, and then you obtain these particular ones. Now, one thing I must remind you about, out of all these formulas, if you observe, in case you forget any of this, you can get them back from this. Yes, you can get them back from your SI units. Once you know how to interpret your SI units, you can regain your formulas back. And I'm giving you this as a tip and as a secret. If there is no question that will come in physics without that has values without these SI units. So it means that if there are questions with SI units, values with SI units, then even if you forget these formulas, you can use the SI units attached getting your formula back. Is that clear? So if a formula looks like output equals quantity multiplied by quantity, it belongs to structure 1, the linear multiplier. This is your secret. Are we together? This is your secret. So let's go to the second structure now. The second structure is the structure called rate of flow and linear ratios. The rate of flow and linear ratios. This structure can come as y equals x over t, or y equals x1 over x2. This is the structure of the second formula structure. Now observe something. All the formulas I'm going to list here, they will take this particular structure. And remember, I told you about 3, right? This is 1, this is 2, this is 3. No matter the structure, no matter how they are grouped, no matter how they are categorized, they still come in 3 parts. All right? It can either be, they will be separated by either multiplication, or separated by addition, or separated by subtraction, or separated by division. But either way, they come in 3s. Oh, is somebody here? If you are with me, please identify. You can see the structure. They are in 3s. They are always in 3s. As we go back to the first one, you can see they are in threes, separated by multiplication sign. You can see it. This one separated by division sign. Yes, that is it. So once you see these secrets, I'm telling you, to memorize physics formula becomes so easy or easier for you. Now, compare a quantity with time. This structure will compare a quantity with time to measure rates or compare two similar quantities to form ratio. Anytime you see division sign, it means ratio. Are we here? So it means ratio anytime you see division sign. Now, one thing I would like to inform you about before I proceed further, a secret I need to give to you now is this. This y changes or varies directly with x. Okay? This y changes directly or varies directly with x. Then this same y varies inversely as t. So what it means is, as y increases, x will t will decrease. As y is increasing, x will also increase. That is it. Once you know the secret, I'm telling you, you will sit well in your exams and you pass fantastically well. So what are the key formulas under this? I have 13 of them. Okay. Now, for the first one, v equals distance over time. Velocity is distance divided by time. Now, observe something. This is the basic formula in physics. In fact, let me tell you one secret. Every other structure is being gotten from this structure. This is the foundation. This is the boss. This is the final boss. This is the original boss. This is the only formula. Yes. Check all your formulas in physics. Yes. This is the foundational formula in physics. Once you realize this, I'm telling you, physics becomes so enjoyable to you. Now, v equals distance over time, and distance is in meter and t in seconds. Now, observe echo under sound wave. This is under linear motion. This is under sound wave echo. Echo, we have distance divided by time, but the distance will multiply by 2. Why? Because of this. Okay, from the position of the man to the wall is d, and once the sound travels this way, it will return this way. Hence we are having d plus d, which gives you 2d, giving you a pictorial explanation to echo. I hope this is fantastic to you today. Now, for these we have what we call wave speed, velocity, wavelength divided by time period. Is still the same structure with this. All right, velocity, distance is in meter, wavelength is in meter, time is in meter, period is in meter. So we are still dealing with the same formula, but being rebranded to give you wave speed. And for wave speed, you get it from this. You can see your period, the time taken to complete one oscillation, and then wavelength, the distance between two successive crests or two successive troughs. You can see that happening. Then we have our acceleration now. Okay, is delta v over t. Acceleration is change in velocity over time. Acceleration a equals delta v over t. When I said this formula is a foundational formula, you will now see that this formula is captured here, and this is the structure used in generating this one. So acceleration is higher than velocity when you're talking about speed. Exactly. This is the third category of speed. So you're having this. Take note of it. Then under current electricity, we have current equals quantity of charge divided by time. Quantity of charge divided by time. Are you here? Look at the structure. Okay, so all this relates to motion. In case you don't, let me give you one secret now. All this relates to motion, movement. You call it current if charge is in motion. All right, but if charges are not in motion, we say they are charged. So please take note of this particular structure. Then let's look at this particular one now, where power equals work over time. Energy, the same thing. So direction is still similar structure here. Because if you find your constant, which is your refractive index, you'll see it is taking a shape. The refractive index, the ratio of the speed of light to the speed vacuum. So that is what we have here. So basically, this is your reflection. The angle of incidence equals to the angle of reflection based on light waves. And then for refraction also, we have the first medium, which is air, and the second medium, which is water or glass medium. It is structure. So look at the structure now. You can see refractive index equals sine theta 1 over sine theta 2, and this gives you Snell's law, the first and the second law. And then I will move you now straight to fundamental frequency in open pipe and closed pipe. You can see it's still the same structure. Frequency. Once you understand this velocity equals distance wavelength, which is wave speed, equals, let me clean this so that you see it properly. Velocity equals wavelength over period. You can bring in frequency to this, isn't it? This, you now have frequency. And when you make frequency, and then under sound, we know that for open and closed pipes, okay, we don't use wavelength directly, we use L. So our wavelength can either be 2L, okay, either 1 upon 2L, or wavelength can be 1 upon 4L, anyhow it comes, depending on the type of pipe. Showed this particular topic in my live, the previous stretch string. They take the same shape and formula. So we have F equals V over 2L. You can see that this structure is almost similar to echo formula. All right. Then for closed pipe, the only difference is 4L. So F equals V over 4L. Take note of all these particular aspects. Then for transformers, we have voltage in the secondary equals number of turns in the secondary divided by number of turns in the primary, or voltage in the secondary equals current in the primary divided by current in the secondary. You can see it's still the same particular shape. All right, look at the transformer here. Look at how it is structured. And then under magnification, mirror now, you can see that magnification equals image over objects. M equals V over U. M equals V over U. If you check your first equation of motion, you will see that this is similar to whatever you are having. So this is your open pipe. All right, this is how we get our 2L, and this is how this relates to closed pipe. This is for open pipe and for string, all captured into one. Is that clear? And then we have for closed pipe, this is the difference, because this will be divided into half again. And then for Snell's law, we have this. For magnification, this is your formula. So take note of this particular structure. And these are your SI units. All right. In case you forget this, I told you you can use your SI units to obtain these formulas. So remember, if the formula has a denominator, with time, it is a rate. Take note of it when you are defining, in case you are asked to define. Then if the formula has one quantity divided by another, it is a ratio. Also take note of this. So structure 2 is all about rates and ratio. Structure 2 is all about rates and ratio. So remember or recall that this structure compares a quantity with time, the rate of flow. Then structure number 2 also compares one quantity with another ratio. Then this structure is being used in waves and optics and electricity, even in sound waves. Then this structure number 2 includes ratios, reflection, refraction, and frequency. You can see that this structure helps to describe speed indices and transformer, the relationship between them. And then this structure helps to in the core of wave motion, optics and AC system. You can see that what I did here is to make the whole of physics easier and simpler for you to understand. So this second structure has captured almost how many different topics? More than 13 different topics. So take note of that. Then we'll go to the next structure, which is the structure number 3. The structure number 3, we call them the exponential growth and half square scaling. Exponential growth and half square scaling. How is this being operated? This is operated in the form of y, okay, equals 1 over 2 multiplied by z squared. All right, 1 over 2 multiplied by z squared. This is the structure of this. So you can calculate total quantity when a system accelerates or build up energy. One key variable is always squared. One key variable is always squared. So take note of this. It's just like saying y equals 1 over 2 z squared. I believe you have seen some formulas coming in this structure. Number one formula is for kinetic energy, half mv squared. Can you see it? Half mv squared. Half mv squared. So this multiplication sign can take the place of a value. I don't know if you're following. This x can represent a value. This z can represent a value, even though I have multiplication sign here. All right. So take note of this. So ke equals 1 over 2 mv squared. One of the variable is squared. Then u equals 1 over 2 kx squared under elastic potential energy. This is under kinetic energy. Then under electrical potential energy in capacitor, you have half cv squared. If you love this tutorial so far, give us a thumbs up, drop your comments and subscribe. Also share to your friends, because you can see I've made your work very easier for you. Different topics, but look at the structure of the formulas and how they are arranged. For distance under acceleration, we have distance equals half squared. So this is the original formula. Let me break it down to you. You see this one here? This is the original, the final boss. It is from this that all others are gotten. Then we now have h equals half I squared RT. Remember, heat energy. You can see the structure. Look at the structures for Joule's heating under laws. So the pattern recognition, energy divided by distance or heat, built up by a changing factor. One factor is squared, multiply and take half. You have the structure. So this is our structure. This is the third structure. If somebody here all follow the same half square structure, please take note of this table. I gave you this. I did my research in order to make your work easier and so you pass your exams perfectly. So look at this. Involves the structure. These third structures involve one quantity being squared, like z squared, used in energy, acceleration, and accumulated effects. This is where you apply this. Represent growth, build up, or storage process. Then occurs when a system changes with time or is being deformed. Take note. And then common in mechanics, electricity, thermodynamics, and waves. So you can see for kinetic energy, you have this car moving with velocity here. All right. Energy possessed by a body due to motion. It depends on mass and the square of velocity. All right. Then for this second one, you will see that elastic potential energy, okay, equals half kx squared. This is it. Energy stored in a spring or even a string when stretched or compressed will give you this particular structure. And then we have another one here, electrical potential energy in capacitors, U equals half CV squared. and you have your circuit diagram here. Energy stored in a capacitor when charged to a voltage V, and then you have the structure be given to you. And then we have the distance under acceleration. We have this distance, we have our time taken for the distance, and we have our initial speed or velocity. Distance covered by a body starting from rest under uniform acceleration, so that you have these particular SI units and parameters. Then the last one under this, we now have what? Joule's heating laws. Heat H equals I square RT, and you have this. This is your source of heat, your R, and then you have your current flowing, and then you have a voltage. Heat produced in a resistor due to electric current flowing for time T, and then you have this combination. I hope you are learning from this. So please take note of this table, take note of the SI units given to you, take notes of these simple explanations, and then remember that you look for a square term, all right, a changing system, energy, the distance or the heat being calculated, and you have the structure y equals half xz squared. Take note of all these particular structure at a glance. So let's go to the final one now. All right, I only gave you 4 structures, and if you're able to understand these 4 structures, we have almost covered the whole of physics. Now the last structure is what we call these balances. Now equations that combine initial values, fractional changes, and inverse relationship balances. Now take note of this. In this structure, it combines initial values with changes. In this structure, it tracks fractional changes from reference states. And then it uses inverse relationship and balances. And then it appears in motion, in thermal expansion, in optics and circuits, essential for solving real-life problems. Take note of this particular structure. And how can you recognize the pattern? We have the initial state plus the change divided by the effect plus the state. This will combine addition or use inverse balances, which gives you the fourth structure. So you can see that this is basically under equilibrium. It gives you the idea of equilibrium, balancing initial values and inverse terms. So let's look at them one after the other. You see the first one here is the alpha. Under linear expansivity, alpha equals delta L over L naught multiplied by delta theta. All right, you can see that it is given this way. Look at the structure here, where alpha is your linear expansivity, your change in length. Okay, you can have your L2 minus L1 and so on and so forth. Then we have the structure, the second structure, which is the first equation of motion. V equals U plus AT. These are also the foundational formulas. Take note of this. Now you can see that V, okay, which is the final velocity, equals U, the initial, plus AT, A and T together being multiplied under this, considering this particular motion. Then I have the second equation of motion, taking the place of S equals UT plus half AT squared. Look at it. U, final velocity, this together, and this structure gives you the second equation of motion. Look at the third equation of motion. Also, you can see also the structure that is being treated here. The first equation, our time is being replaced with distance and also distance here. If you observe the structure, you understand the concept. And once you see this concept, you know how these formulas are generated based on these diagrams you are seeing. Please take note of these explanations because they will help you in making your work easier to do. Then we have distance in the nth second. You can be asked to find the distance in the nth second. So S of n equals U plus A over 2 into 2n minus 1. This, if you remember mathematics, yes, you have a formula that is similar to this. All right, then look at it here. This is what I'm referring to. distance in nth second. So take note of this structure. Then we now have the mirror equation. You can see also, let me remind you, because I have not spoken about it, even though I related them to you from the beginning. How many parts are this formula written in? You can see that they are still in three. 1, 2, 3. 1, 2, 3. 1, 2, 3. Check all of them. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Can you see it? Everything in physics operates in threes. So if you understand this concept, I'm telling you, you remember your formulas and you pass your exams fantastically well. So for mirror equation, take note of this particular equation and what F represent, U represent, and V represents. Under mirror equation is different from motion because you can see both U and V sufficing under mirror equation, and also under lenses. You can see for lens, for mirror equation, you have positive sign. For lens, you have negative sign here. And for resistors in parallel, capacitors in series, inductors in parallel, you use this method. All right, even though I didn't capture capacitor and inductor, but take note of this. We resolve resistors in series in parallel the same way you resolve inductors in parallel. Then you resolve capacitors in series the same way you resolve resistors in parallel and inductors in parallel. Take note of these. Then quickly, as we bring this class to a close, remember that all these equations are given to you so that they can help you solve problems. And once you see how the structures are formed, then it becomes easier for you to memorize these formulas. So, alpha measures how length changes with temperature. Equations 2 to 5 describe motion with constant acceleration, where you have initial velocity, final velocity, displacement, and time. Equations 6 and 7 are the inverse laws of reflection and the refraction. Okay, then equation 8 is for resistors connected in parallels. So remember, use structure 4 when a change is measured from an initial value. You use it when inverse or when inverses 1 over x are involved. So you use them in balancing two sides, either in optics or in circuits, electric circuits. So today, I believe you master these formulas, and there will be more tutorials on how to see you pass your exams perfectly. If you have not subscribed, please do so now so that you will be reminded of our latest and subsequent uploads. In this particular tutorial, I will see you in the next one.